Hey, welcome to our live webcast. I'm Wayne Anderson, Product Specialist Sales Manager for Okuma America, and also the host of Okuma's sponsored podcast, Shop Matters. Joining me today is Rocky Helms. He is the brain trust of all things manufacturing related here at RCR, Richard Childress Racing. Rocky is the Director of Manufacturing and is somebody who's going to be able to really step us through all of the development and manufacturing that went into developing the first next-gen race car, as well as some of the components that they're producing for the car here. So we're going to spend a little bit of time today walking through some of that. We're going to talk about some of the manufacturing that we do here at Richard Childress Racing. And then after that, we're going to open it up to a live Q&A session with everybody from the audience here. So we are coming to you live from Richard Childress's Cup Shop, the headquarters here in Welcome, North Carolina. I highly encourage anybody watching today, if you haven't been here, it's worth taking a Saturday or taking a day trip up, spend some time in Welcome, come to the Richard Childress compound here, the museum and the Cup Shop. It's an amazing facility. So Rocky, thank you for hosting us here today.
Glad to be here, Wade. Appreciate it a lot.
Yeah, so take a few minutes and just tell us a little bit about your background. How did you get into the racing circle?
So I grew up in not too far from here, about an hour and 10, 15 minutes in Stuart, Virginia, which obviously is, as most people that follow racing know, that's home of the Wood brothers. So I grew up around the racing, being local to that area and stuff. So I'd always kind of been involved, been interested in it. I raced go-karts for several years, got into the manufacturing side of things. 17 years old when I was still a high school senior, I got my first job working in a machine shop. Spent a year there, graduated, thought maybe I'll ask the Wood brothers for a part-time job, just doing whatever. So kind of walked in and lo and behold, they hired me 3 months after I got out of high school. So I kind of got involved in racing at that point, was still doing manufacturing. So I worked there during the day and I've been promoted to a second shift supervisor at the manufacturing facility I was at. So worked 2 full-time jobs for a couple of years. And then went on to college later for doing manufacturing and stuff. And then that's kind of what landed me here at Richard Childress Racing a few years later.
Okay. I think that's funny. I think a lot of people that I talk to in the industry, I was the same way. I started cutting chips right out of high school. And there's a lot of us that either did it during high school or right out of high school. And it kind of gets in your blood after a while, you know, and it's hard to get out of that industry once you're in it and start doing stuff like that. So very good. So last time we were together, we had shared some stories. You know, I go back to watching racing with my dad as a kid. You know, it was just part of the blood, growing up. And even when my wife and I first got married, we planned all of our weekends. Everything we did during race season was planned around where the race is at, things of that nature. And I always remember Richard Childress Racing. For me, it was always synonymous. You'd see that black car with the red RCR on it. So you shared some stories with me about the first time you had an encounter with Dillon Earnhardt. Do you mind kind of sharing a little bit of that?
Yeah, no problem. So I started, like I said, right out of high school. So I was only 18 years old and been there about a year. They decided they was going to take me on the road for a few races. So it was the first time I'd ever been to a actual cup event and down in the pits in the garage area and stuff like that. So
you're so wet behind the ears.
Oh yeah, big time. And especially when you're the young guy, they like to pick at you anyway. There's a joke kind of goes around the garage area when the new kid shows up, they'll send you to the back to the garage or whatever and tell you that they need one of them's a metric long weight. So they'll tell the kid that's new, like, hey, can you go over to the 24 team and get our metric long weight that we forgot about? You know, we let them borrow it last week, and 9 times out of 10, they don't have any idea. You know, they run down, they ask for it, and then they just send you to another team. Mm-hmm. And then they send you to another team. First thing you know, you went to half the garage looking for something that doesn't exist. Yeah. So that one had already been played out, and I knew what was coming, so I wasn't going to fall for that. But I was going to the racetrack, and we were at Martinsville, so that was local to me. First race I'd been to in the garage. And at that time, there was no garage, so you were pitted on pit road during practice on Friday. So you're running back and forth from there to the hauler to get a shock or a spring or whatever. And so Eddie Wood had told me, can you run over and get this spring? So I'd go to the hauler. I'd probably been doing that several different times and kind of got relaxed and wasn't necessarily paying attention real good and running back to the hauler. And so when the cars come off the track, they have to get to the gasoline area. to top back off and check their fuel mileage and stuff like that. So I hop over the wall and I take off, and I kind of look and didn't see anything. So I just take off running, and all of a sudden I hear somebody hollering at me. It's a NASCAR official, and I look, and the 3 car is flying towards me. Like he saw me and then was hauling butt to get towards me and kind of scared me or whatever. So I kind of run through, and growing up, I wasn't that I was a big Earnhardt fan, but the Intimidator and all that. And my first instinct was, man, he really is kind of arrogant or whatever. I'm just walking through the garage and he's going to try to run me over. So I kind of run out of the way and don't think much about it. Well, then the official stops me and points back, and I turn around, and Earnhardt's sitting there, and he's looking through the passenger side. He's got his open face helmet and his goggles on, and he motions for me to come towards him. So I'm thinking, what the heck did I do? I mean, you were the one that almost run over me. I didn't really run out in front of you. So I walk back towards the car, and I'm very reluctant. By this time, there's fans kind of looking around, and there's people taking pictures.
Their cameras.
Yeah, anywhere his car stopped or he was at, there were pictures. So I kind of look down, and he motions for me. He's like, over here. He wants me to come around to the driver's side. So I'm going around in front of the car, scared to death. I mean, I'm petrified. And I get over and I lean down, and he motions again, get down here closer so I can see you. So, and he's got this mean look on his face, like I'm getting ready to get chewed out for something.
Right.
So I lean a little bit closer, and then it's this big, huge smile. Hey, are you new? And I was like, yes, sir. He said, I see you got Wood Brothers. You work for the Woodsies? That's what he called them a lot of times. And I said, yes, sir. He said, yeah, I saw you coming when I was coming off a track. I saw you coming across there. He said, I figured I was going to mess with you and make you and scare you a little bit. And, of course he did. So he just chit chats for, 10 or 15 seconds. And he goes on his way, and I go on, and I get back and I have to explain why I'm a little bit late getting back, with what they sent me for. So practice is over probably 45 minutes later, and I'm in the hauler, and one of the pit crew, one of the guys on the team comes to me, and he says, hey, somebody back here wants to holler at you. I'm thinking, who knows me? I mean, it's my first race to the track. And I go back to the back of the hauler, and Earnhardt had come up in there. He's like, yeah, that's him. That's the new guy. And of course I come down there, and he asked me my name and all that, but it was interesting. It was an experience, and one I'll never forget for sure.
Oh, absolutely. So talk me through a little bit of the next gen car. You guys have been really involved with it from the beginning. So talk about how you got involved with it and the purpose behind it.
Yeah. So the teams the owners specifically, they're looking at trying to find ways to drive down costs. It's getting really astronomical with all the big teams and stuff. When I got in racing, there were no engineers at the Wood Brothers, and I think Bobby Hutchins was like one of the first engineers in all of racing. So now, teams have 30 and 40 engineers. They got more engineers than we even had on the team back then. So the specialization of the car has increased a lot. The aerodynamics, the wind tunnel, and all that stuff, everything that's involved. So the costs just keep going up. So that was part of it. Is NASCAR was looking to try to find a way to help the teams, and to also bring new manufacturers in, and to bring new teams that can compete on the same level without having to have the tens of millions of dollars to fund it. And as cars have become so specialized, we have several technical alliances that we supply them their car. Well, if you buy a chassis from us, then you had to have our suspension components, and you would have to run our engine and things like that. So that kind of locked you in. And the biggest thing was everything changes weekly. So you go to the track and you find out real quick that you need this part that's a little better, or that part that's a little better. And going back to the cost side, our annual budget for my department alone in the manufacturing side is more than what, when I got into racing, the entire team budget was to operate for the entire year. Wow. So when I got into racing, Richard Childress had 2 CNCs, maybe 1 or 2 other teams had 1 or 2, and that was it. There was no in-house manufacturing at all, really. So now, like I said, we're spending as much on manufacturing a different component every week, than what teams were spending on the entire yearly budget before. So that was part of what was driving it. And then also the competition side. Mm-hmm. They, want to bring better competition into the sport, try to help with the cost. And when you put both of those together, that was kind of what what sparked it from the beginning. Fast forward to how we got involved. So in 2019, that was when the concept had been discussed before, but that's when they had contracted Dallara to help develop the car and design the car. And we were picked as the contractor to build the very first one. We called it P1, to build the very first prototype. So I remember we got our very first purchase order the middle of August, and that was for some suspension components, and it was for some fixturing for building the chassis. Obviously, that's where we had to start.
And you get like a 2-year lead time?
Yeah, they gave us, believe it or not, it was 6 weeks. It was
6 weeks.
From the time we got the first purchase order, the middle of August, the very first test for this car was going to be the first week of October. So we had 2 weeks in August and the month of September to have a brand new, completely different car than anything we'd ever done. It definitely was a team effort from everybody at RCR, not just the manufacturing. Our engineering group jumped in big time because they were obviously the very forefront of it. They were working with Dallara. Dallara had not designed specifically, this type of car, so they worked closely with a team. But believe it or not, it was actually very, very phenomenal. The job they done, very few tweaks had to be made for this prototype. And everybody was very surprised at how quickly it all happened, and honestly how pain-free it was to get everything done. So we started with the chassis department. They had to get that part done. So we were unfortunately kind of involved in it from start to finish. Like the chassis part got done, and then they're kind of finished with their portion of it. Then the body side had to get the body of the car manufactured and put on the car, and then you had the assembly side having to do all the assembly of the suspension components and all that stuff. Now, granted, there were some parts that were some carryovers from other things that Dallara had, so we didn't have to necessarily manufacture every part, but a big majority, especially the chassis, there was nothing for that. So everything related to the chassis was manufactured. The concept of this car is a center section and then a bolt-on front clip and a bolt-on rear clip.
Okay.
So it's a little bit more modular of a deal. We're not going to have specific cars anymore for road course and short track and intermediates and speedways and super speedways. Now this is the chassis, and it's across the board. It's the same for everyone. We actually had a couple of engineers that they took from our normal engineering group and stationed them in the chassis shop from the beginning, because there was a whole lot of, this was the very first car we had ever built where, the guys in the chassis shop had the CAD up, because some of the stuff, there was no drawings for it at that point.
Sure.
Some of the things were changing on the fly. This doesn't fit exactly right, so we're going to have to redesign kind of on the fly to do it.
Okay. So some of the technology that goes into the new car, it really brings you up in technology to today's technology of what you're seeing on cars versus what you had in the previous generation.
Exactly. That was another driving force with the whole next gen concept. Is what we're racing currently is honestly a 50-year-old technology. It's truck arm suspension. It's based off of, something in the 60s. We have a lot of built-in things that we can do to tweak the car and make it faster, but the geometry is still the same. Truck arm, solid, rear end housing, stuff like that. So stepping into the next gen, now that's independent rear suspension, which was something different for us, but it puts you more in line with the passenger car. So one of the things that's said a lot of times about the next gen from some fans is, well, it's not stock car racing. It's not like it was. And honestly, if you go back, it hasn't been stock car racing for a lot longer than 20 or 30 years. I mean, it goes back further than that. When I got into it, it was tube chassis then. And, some of it's been said that we're taking some of the ingenuity out or whatever. Again, when I got started in 94, we purchased a chassis. We purchased our spindles. We purchased the center links, the idlers, the pitmans. We weren't manufacturing a lot of these parts that we do now back then.
Right.
And people say, oh, well, the competition was better 30 years ago. So NASCAR is looking at that. That's what we're going to be doing again, is putting everybody a little bit level playing field from the parts and pieces standpoint. It's what you do with them from a driver standpoint, the interaction of the crew and the crew chief and the driver of getting the feedback and making your car better. Going into the parts and stuff, like I said, there's more stuff on this car that resemble the Camaro that you can buy off of the showroom than what we currently are racing today, or what we just finished the season with.
Yeah. Now you guys had a incident recently in the testing. Tell me a little bit about what took place there.
So this literally just happened yesterday. We're testing at Charlotte. And 10 minutes into the practice, Austin had an unfortunate accident and hit the wall, and it was a pretty good lick. I mean, I saw pictures of the car, and it tore it up really good. It would have been, I talked to our head over production here, Royce McGee, earlier, and, it would have been a wipeout of a car, the current car that we have. Mm-hmm. So they got the car back from the track here at 11:45, right before lunch yesterday. Everybody flogged on the car. They pulled the motor out. It had had a messed up bell housing and had a bent motor plate. So that goes to the engine shop. They done their deal and fixed that. They jumped on the car, and Royce was telling me that, one of the benefits of this is there's a front clip sitting over there that they had suspension already bolted up to. They already had front end geometry figured out. And he said, luckily it was the same type setup as what they were using at Charlotte. So they pulled this off. He showed me some pictures of the mangled up mess they were taking off. Left front suspension was destroyed. Right front was okay. So they put this front clip on, put a new motor, or put the motor in that it just went to the engine shop back in. And he told me at by 2 o'clock, they were back on, they were putting the body panels on.
That's incredible.
So they put body panels on. They went to the setup plate. They ran through. They went back through their Hawkeye for scanning. And he said they loaded up. They were gone by 5:45. So it's only been about 6 hours from the time the car arrived until the time the car is rebuilt and going back to the track. And I didn't know this until I talked to him. They actually got back to the track yesterday before 7 o'clock, unloaded, and got to make 3 runs.
Wow.
So the same car that they wrecked earlier that morning was rebuilt and back and on the track within 7 hours and making laps again.
So while you hate to tear up equipment, that was a really good kind of a proof to,
and they're actually
succeed.
Exactly. They're actually working on cost analysis now. He was telling me earlier that him and Sammy Johns, our competition director, are working on cost analysis for NASCAR. What did that cost you in manpower hours and parts and pieces? And so they can compare and let teams know where we stand. It would have been a wipeout of a $30,000 chassis before.
Right.
And it would have spent longer getting disassembled, to find out that it was not repairable than it did for them to repair the car and get it back on the track.
Yeah, that's incredible. So we've been involved with RCR for roughly 20 years now. I shouldn't even say roughly. We're actually celebrating our 20th year as working together and being a sponsor with RCR. So tell me a little bit about the history, and you were here during that time when we came on board.
Yeah, so that was the main reason, that I enjoyed my job at the Wood Brothers a lot. And that was the only reason I came here was the manufacturing side. I wanted to put my 2 loves were racing and manufacturing. I wanted to put those together. And I was aware that Richard had 2 CNCs in his engine shop, which is where 99% of all the manufacturing originated, was teams buying it for cylinder head manufacturing and intake manifolds and pistons and stuff. So that was what drew me to come here in the first place. And as luck would have it, I came here in September of '99. And it's kind of funny and ironic is the person that done HR at that time, Webster Schweisfield, was actually out of town on a hunting trip in Alabama, turkey hunting. So I had to go to the executive vice president, which was the backup HR person back then, which was Bill Patterson, to do my paperwork. So I'm filling out, my paperwork and stuff, and he's just looking at it. And he said, noticed I had a manufacturing background. He said, that's interesting. He said, we're working on something that you might be interested in. He couldn't tell me what it was, just said that they were working on something, and asked if I might be interested, because I was being hired as a machinist and fabricator for the newly formed Xfinity teams, which at that time were Busch teams, for Kevin Harvick and Mike Dillon.
Okay.
And so that was actually what brought me here was that deal. And, like I said, the way the luck fell, I'm filling out paperwork to somebody that knows about something that's being worked on behind the scenes. So long story short, he told me that he would keep me informed and let me know if that's something I was interested in. Maybe there would be an opening for me to transition to the manufacturing. So following year 2000 is when they made the announcement at Charlotte that we were forming a partnership with Okuma. Mm-hmm. And honestly, it wasn't but about 2 weeks after that, they transferred me to manufacturing department, and we branched off from the engine shop and became our own entity, our own department. And that was really where we took off on the manufacturing side. We went from doing 3 or 4 engine components to now started doing spindles and the chassis components and things for engineering. We were actually integrated with the engineering department in the same building. Engineering was in the front, and they were expanding that at the same time, and then we were in the back. And five new Okumas came in, and two of those machines we still, when you've toured down there, we still have those on the floor, an MX-55 and an MA-50 HB horizontal.
Yeah.
Same two machines that came in the door in 2000.
Yeah, that's incredible. I enjoy every time I walk in there. It kind of takes me down memory lane because you get to see things going back 20 years from machine technology, the older vertical machining centers, the older horizontals, all the way up to our latest generation of machine tools. So you guys have been moving into an automation type environment for a little while now. You have a horizontal with a pallet pool. Tell me a little bit about the pallet pool and the type of work that typically you would see go through that cell.
Right. So the main reason I was wanting the MB5000 with the pallet pool was we do a very unique mix where I tell a lot of people we're a glorified job shop. Mm-hmm. We're job shop type work, not necessarily a manufacturer of a few components. And it's a big mix, and it's changing constantly every week. So a lot of times we're getting some orders from the engine shop for, say, a motor plate or whatever, and they might order 20 or 30, but they really need 2 or 3 now. And then there's 3 or 4 other parts that are also on order, and they need 5 of this one and 5 of this one. And, you don't want to be setting up and tearing down going between all of those. So with the pallet pool system, the horizontal already had 2 pallets, which, we've been used to that for the last 20 years. But with the pallet pool system, we've got dedicated fixturing and tombstones that we can bounce between the different parts. And if, sometimes you get involved in manufacturing a part and you get the first 3 or 4 and they go to the track and they kind of hold you up to see how that goes. You go on to something else. And then the feedback coming back is, well, we need some more, but we need to tweak this and this and this. Mm-hmm. So instead of shutting down the entire production line, then you can bounce over to this other part while the programmer's updating his side, and you're getting going on the new version. We are getting into some contract manufacturing. So we were wanting to get in more of the automation. As everyone knows, the labor pool is shrinking more and more. So we knew it was somewhere we needed to head. We needed to get to that direction. But with the horizontal and stuff, and now we've got the some of the other machines that we'll get to on the automation side. It was mainly because of the mixture of low volume, high mix parts that originally got us headed in that direction.
Yeah, excellent. So the next gen car has forced you guys to look at manufacturing a little bit differently with the type of work that you bring into the shop. So you mentioned you're doing basically more job shop type work as well, but you guys also have a contract to do some of the work for the next gen car. Tell me a little bit about the component here and what led you down to that path.
Yeah, so since we were involved early on in manufacturing, biggest majority of the components, the suspension components and the chassis and stuff like that, part of the concept that Nascar has with this is they were going to put specific sub-assemblies out and certain parts for bid, and it didn't go to the low bidder or whatever. It was, they looked for people that already had a background in that type of environment, whether it was racing or whatever, or, like in an instance of the steering woodward component, they already do steering components for a lot of industries. So they had a background there at Brembo brakes and AP brakes and all the other people that have a background in that stuff. So they went towards those people for certain areas. And then when it comes to the machine components, they put that out, and there was invitations to bid. So we put together some bids, and it was made up of a panel. It wasn't just Nascar selecting who it was going to be. It was a big panel. It was made up of executives and people at NASCAR, people from the competition side of NASCAR, along with team representatives. So when we went to do our presentations, it was in front of a panel of 14 or 15 people, and there was representatives from all of the teams and the manufacturers, and this was a collective deal with who was going to get the contract. So the one that we wound up with is the single lug nut, which has definitely been a hot topic. Not just the next gen being hot, but the single lug nut itself, because that's a step, in a different direction than what we were accustomed to seeing with the 5 lug nuts that we currently have. So that was the contract that we picked up, and as soon as we got that, we're trying to run through the numbers of figuring out the volumes and stuff. And how often are teams going to use these, how many races before they're fatigued and they want to switch them out. Pit stops are different. The single lug nut is already used in Formula One and IndyCar, but they're not doing nowhere near the pit stops that we're going to be doing. We may be 13, 14 stops, sometimes at the Coke 600 or something. So it's a lot different than 3 or 4 in an F1 race or an Indy race. So that's something that'll still have to be worked out. So not knowing what that anticipated quantity is going to be. Yeah, we have to keep doing what we're doing on the engine side and the other components. Yeah, there'll be less of the race components that we do with the next gen, but there's still the engine side that we're doing. So we need to be able to have the throughput through the shop and not be interfered with on this. So that was where we came into the automation side with getting with Okuma on the Multus Armroid machine and getting our feet wet with more than just the horizontal and the pallet pool, but getting into some real automation.
Sure. So the Multus, that's our mill turn style machine. So it's basically 2 lathe spindles and then a 5-axis H1 or a milling spindle on it. So the way that you're currently doing that, let's start by kind of showing the finished part. I don't know how well that actually shows up on camera, but we'll try to zoom in on this here in a minute. But you're able to do this part complete. So you do op 10, op 20, op 30 with all your milling, or you can separate it out and do just the turning and then do the milling on another machine to balance out the workload in the shop. Is that right?
Right. Yeah.
Okay, so step me through kind of, this is be like your op 10, op 20, step me through your typical production process.
Right. So we knew initially there's going to be, they're going to want to put stuff on the shelf. So there's going to be an initial huge quantity in the hundreds that we needed to get through the shop, because the big thing was, it's funny because we're not racing until obviously February. But once NASCAR, the COVID thing last year really put all of this in a tailspin, because originally this car was supposed to debut this year at Daytona. So all of last year's testing for 2020 was postponed, and we weren't able to do any of that. So that forced us to go into this year with the same car that we have currently and develop this a year later than what NASCAR had on track. So fortunately, though, all the teams have been awarded their contracts. So it gave us this past year to try to get inventory built up and figure out where we were going to be at. The chassis was the big one. Until anybody gets a chassis, they can't start building a car. NASCAR is very good about laying out their timelines of, go back 2 years, we were involved with seeing what the timeline for rolling this car out was. And they had a very detailed plan of crash testing and track testing, and when they were going to do single car tests versus when they were going to do tandem, drafting tests at Daytona and stuff. So they had a very thought out plan of how they were going to implement this car. It wasn't just, build it and give everybody one and we'll see what happens.
Right.
So all of that was done during this past year. So most all the teams received their car in June and July and started building. So, naturally the teams are trying to get as quick of a leg up on everybody as they can. So even though we're not racing right now, all they needed was one set of hub nuts to put on their car that they're practicing and testing. All of the pit crews want to be testing and practicing pit stops now.
Right.
So as soon as it was a go on all this, they're like, we need pits, we need lug nuts. We got to start practicing this single lug pit stop because it's so much different than what we currently do. So there was an initial influx of parts wanted right away. So we wanted to be to that as demand was. So again, we're, like I said before, it's kind of like a job shop. We're not just making this one component forever on one particular machine. So we have 2 options. One is a Genos L300M with live tooling and stuff that we can do just the op 10 and 20 and make a turn blank like this. And then we can go to a 5-axis machine to come in and do the pocketing and the slots and the thread milling.
Okay.
The other option is the Multus, the Armroid machine, doing everything, transfer and all the 5-axis machining and everything.
Okay.
So there is no difference in total time. It's only a couple minutes difference between this way on a lathe and a mill and this fully done in the Multus. The biggest difference was throughput. If the distributor needs 200 of them ASAP, then we'll go this route to get them through the shop quicker, splitting it between 2 machines. Now that we've gotten some inventory to the teams and the distributor has some inventory, now we can go back to a single machine throughput.
Okay. Now the automation You mentioned this machine runs our Armroid system. That's a robot that's built by Okuma, mounts inside the machine over the headstock. It will load parts, it will do a coolant wash, and if you're doing shaft work, it's got steady rollers basically that'll follow the cut to provide damping and support to long shafts, things of that nature. In this case, you're bringing these parts in basically slugged. How much stock are you allowing?
There's 50 thou, 25 per side, one for the op 10 and the other 25 for op 20.
And then the machine's got a stocker table. You load up. How many parts are you getting?
Like 36.
36.
Yeah.
Okay. And then the Armroid basically picks in place. It'll pick it off the stocker, load the truck, drop the parts back off. The interesting part about our Armroid and Standroid series is the programming aspect of it. You don't have to have a robot programmer on staff to be able to teach the robot. Tell us a little bit about how the programming works and what you've seen your guys be able to utilize on it.
Yeah. So that was one of the big advantages when I came to Okuma about this machine and this technology was I'd already been looking into automation and robotics and stuff like that, but a lot of times that's high volume stuff, tens of thousands. It takes weeks to get the thing set up and program and tweak in and all. And if you're going to run it for 6 months or a year, that's fine. But what we want to be able to do is we might not run but 200 of these, and then we want to switch to a totally different product line. And we're going to run a couple hundred of those, and we're going to switch to something else. So we wanted the flexibility to be able to reprogram the robot at the machine with the same interface. And the nice thing about the Armroid too is, that with the stacker, you can pull the pin and slide it out of the way, and we can run it like a standalone multis. If we got a prototype part that's only 1 or 2 and we don't need the Armroid at all, that's fine. It's there, but we don't have to utilize it. And then when we go back to this or some other job, it's no different than setting up any other turning job. The nice thing is with the CAS, the collision avoidance system and all that, the robot's doing 90% of the thinking. You're just teaching it a pickup point and then a drop off point for the slug and a pickup and a drop off for your part. And everything from point A to B is done in the background with the Armroid and the process and the model and everything. It's in the control. So actually one of the least experienced guys that I have in the turning department is the guy that got trained on this. Billy O'Day, he had come from the racing side, was a spotter for Harvick for years, wanted to get into the manufacturing, was ready to come off the road and had enough of that. And he had a little bit of CNC. He had a CNC router at home and he done some woodworking, but that was the extent of his machining and manufacturing background. So he's only been in our department about 2 years in the turning side. And he was one of the ones that I got trained on this machine along with our programmer, David Crandall, and then the supervisor in the lathe area, Darren May. Those were the 3 guys that got the training on it. The one that operates it on a daily basis is Billy O'Day, that had the least, like I said, the least amount of experience of those 3. And he takes care of everything. He can be over here running something else, another machine or 2, and be proofing out a prototype part and go over here and take parts, unload parts, and load material back. With the probing onboard probing and everything, we can measure the part, we can check and feed that back in and make offset adjustments. We have redundant tooling set up in the back of the magazine. We know this is one thing that was new for us, was getting into the automation side. And we leaned heavily on the applications people with Okuma. Was we always make five parts and 10 parts and 20. You don't get into tool wear that much unless it's a really unique material. And so the chip control and the tool wear and stuff like that, and how to integrate that into the machining side, besides a machinist measuring it, making an offset adjustment. Or once we learn how many parts we can make before we have to switch and index tools. So we worked with Okuma, specifically Kevin Kraski there, of getting us where we needed to be on the tool wear and how often, and he helped us put all that together.
Fantastic. So how many hours of runtime do you typically run when you're running a full production lot? How many hours of runtime will you run that machine using automation, where it's basically labor free part production?
Yeah, so that was another big benefit of it, was we run a first shift at 6:30 in the morning to 4 in the afternoon, and we have a third shift technically that comes in at 9 at night to 7 in the morning. Okay. So we have 5 hours between the 2 shifts that without this automation would be untapped capacity. So they can make sure the stacker is done before they go home, and it'll run, until third shift is here. And a lot of times we'll just let it run on out until those parts are done in the stacker. And then the following morning when Billy comes back in, he'll follow back up and get it going again.
Okay. It's like all the finish goes off, reload it up, set it back in the cycle.
Yeah.
All right. Excellent. So tell me a little bit about how has the single lug nut changed the game in terms of at the track? I know the gun obviously has been changed. In the past, you guys used to actually manufacture your own gun for the 5 lugs.
Yeah. Yeah, that was another thing that also NASCAR was looking at, was when they were trying to curb the cost and stuff like that. They actually made that change a few years ago. Everybody started, once our manufacturing capability and capacity started getting more and more, we started getting more intricate on the stuff that we were designing in-house. With added engineers, we actually at one time had a full-time engineer dedicated just to pit stop equipment. That was his sole job, was to look at ways to improve the pit gun and the jack and stuff like that. So we manufactured our jack in-house, we manufactured our gun in-house. The only thing we purchased for the gun was the air fitting that screwed in the back. Everything, the housing, all the internals, the sockets. I'll tell you a quick story on that. On the socket side, we were constantly making different iterations of the socket. We would make one that had the nose tapered a certain way, and they would go and practice, and they might not like exactly the way it felt. Right. So they would come back and change the angle. So, we had made probably 12 to 14 different pit gun sockets, just different designs and stuff. So even that was changing every week or two. Sometimes it would change 2 or 3 times in the same week. They would go to our pit stop practice building, practice with that socket, and we don't really like that. Can we change this, and this? And we make 2 or 3 more, and they go try those.
Yeah.
So the cost of the pit gun side was getting high. Teams were spending 7 figures in pit development. So NASCAR a few years ago came and said, okay, Paoli is the gun manufacturer, and everybody uses the same gun, and they bring them to the track. They're issued to the teams. You use them for pit stops, and then you turn it back in. They rebuild it and bring guns back. You don't get the same gun every week or whatever. So that was one of the things that NASCAR looked at when they were.
So kind of shuffle the deck on it. You don't know which gun you're going to get at the next week, right?
Yeah. So I've talked to some of the pit crew guys, specifically the tire changers, since they've got to work with this now for a little while, and like one of the guys was telling me, it's not going to change the competition side. That's always going to be there. Mm-hmm. It's like anything in racing. If you take one aspect of it out, all you're doing is shuffling it somewhere else. Now they're going to have to find tenths or hundredths of a second in another area. Right. So it's still, you got to be just as athletic as you was before. Now it's more important about getting to the car quicker than the other guy. Mm-hmm. Before maybe your hand speed could make up for, maybe you couldn't get to the car as quick as another guy, but man, I got fast hands. I can make up a little time there. Okay. Well, now that's not even, it's still important, but now that aspect's changed. So it's getting to the car. It's getting around the car to the other side. It's the exchange of the tire coming off and the tire going on. So it's still just as competitive as it was before. And I actually talked to the head over vehicle development and stuff for NASCAR, Brandon Thomas, who is over this entire next gen rollout and everything. And we've been working with him for several years on the next gen project. I reached out to him, asking some questions about the lug nut and stuff like that. And he brought up a good point that when you have the steel wheel, you can leave 1 or 2 lug nuts a little bit loose. Everybody knows they do it on that last pit stop, 5 to go and you need to beat the guy out. All 5 don't get tight. Yeah. 4 don't even get tight. Maybe it's 3 or whatever. Well, the steel wheel.
3.5.
Exactly. It's just enough to keep it from coming off for 5 laps or however many's left. Yeah. But like Brandon was saying, the stress and the loads and stuff on a steel wheel, it could take just 3 or 4 lug nuts being tight or not even completely tight. With an aluminum wheel, like what the car has now, again, resembles the production car more. It's an 18-inch aluminum wheel. But like he was saying, if you put 3 lug nuts on it and barrel off in the corner at Atlanta at over 200 miles an hour, it's not going to take that too many times and something's going to break. Yeah. So this was more a safety thing than anything. Okay. With the aluminum wheel, and yeah, you can leave a few lug nuts off on your passenger car going 65 down the road, and taking turns, but at 200, and yeah, it's a little bit different. So that was part of the idea with safety.
Okay.
With going to the single lug nut. It didn't have anything to do with the competition side or anything like that. And it also is, in the long run, a cost savings on the team side. They're taking, 400 lug nuts, there's, five, it's 20 per stop. And, even if for only $1.50 or whatever they got in it, one of the things that all the teams always done, it was one of my first jobs at the Wood Brothers at 18 years old, with chasing lug nuts.
Yeah.
So, you get a whole box of lug nuts and you're chasing them and making sure the threads are clean, and then you're spray painting them all with a fluorescent color so that they'll show up, and putting them in a box. Well, I mean, there's somebody that's doing that. So they got their time, and then, they're one and done. So 10 stops, there's 200 lug nuts, where this is reusable over and over and over.
Right.
So it was an inventory and a cost, and then also a safety factor.
Okay.
And honestly, it will make the competition even a little bit tighter on the pit stop side.
Right. All right. Excellent. Well, let's take a break there, and let's open it up to some Q&A from the audience. We've got our lovely Miss Kelly behind the scenes here that's going to man the questions as they come in and call them out to us.
Yes. So first question here, is there a right and left version of the lug nut?
Actually, there is not. Both of them. Both sides are a left-hand thread.
Okay.
It has a safety mechanism built into it with these little slots that you see here. The hub and the hubcap assembly have spring-loaded pins that once it goes on, they lock into this, and you have to put the socket on to depress them to be able to bring it off. So it's not that it couldn't necessarily loosen up, but it can't come, theoretically, it can't come completely off.
Okay. It's interesting.
All right. Next question here. What are you most looking forward to next season?
I'm going to say, from our standpoint, is going to be the competition side.
Yeah.
We've done a lot of testing on this car, so knowing what to expect. We've even talked to Austin or whatever. We asked him some questions in the last few weeks about the drivability and stuff like that. And, he said the steering reacts a lot quicker. The braking is massive. It stops so much quicker than the current car. So you're going to see guys, driving down in the corner a whole lot deeper before to get under the guy than they did before. And they might make it and they might not.
Yeah.
The car, from what I've heard from a driver's standpoint, is the car can get away from you a lot quicker. Maybe not as forgiving in some instances on losing control, and it's gone. So the competition side, I feel like, is going to definitely, one thing we're definitely excited about to see how all that plays out.
Okay. What's been the driver feedback so far that you've heard, at least from the RCR team on the car?
Everything that I've heard has been real positive as far as really enjoying the car, and like I said, the feel that they get back, the way it reacts to changes that you make to the car. That's the biggest thing probably that everybody's learning a little bit, is we know what all the tools were we had before. We knew when we changed this shim and that and this upper or lower control arm and caster and camber, you knew how it all reacted. And the vehicle dynamics are the same, the theory and everything, but we got different tools to work with now than what we had before. The biggest difference is probably obviously going to be the independent rear suspension. So they have some more things that they can adjust and do things with than what they had previously.
All right, next question here. How quickly can you produce a set of lug nuts for a race? What's that turnaround time look like?
If we had to if they come in and said we need one set, you're looking at probably about 2 hours to do a complete set. If we do it this option here, these two ops, and then this right here, it's probably a little bit less than that. If we do it all on one machine, it's basically about 1 hour for the complete thing. Complete hub nut. One of the things that there's a lot of detail in it that you can't really see without looking at it. But
yeah, I don't know if I can get that up to the camera close enough.
There's a lot of 5-axis machining in here because of the pockets and the way that they neck down. There's no manual deburring, so all the radiuses and stuff you see are surface machined on 3D. So that adds a little bit of time to it. The design of it with the small ball mills that have to be used, the material, the type of material that it is. makes the machine a little bit more difficult too. So we end up with about 1 hour this way, and so 4 hours for a set, and this method is 2 hours.
Okay.
All right, next question is for Wade. Can you share with us a little bit more about Armroid and this automation technology in Rocky's shop?
Sure. So the Armroid, that's an Okuma built robot. So we have basically two different flavors. We have a Standroid, which is an external robot. That's a purchased robot that stands outside of the machine in a separate cabinet, where the Armroid is actually built inside the machine. It runs harmonic drives, and the real beauty behind it is, Rocky touched on it a little bit, is there's no real programming to the robot itself. You teach it where to grab the part. And so if you're grabbing a shaft, for an example, where you have a heavier end, maybe you've got something hanging off one end in a shaft, you teach it where you want to pick up at. So you've got a balanced pickup point. And then you teach it where in the work holding you're going to load the part. But getting inside and out of the machine, all of that motion path is taught, basically self-taught. It's looking at our collision avoidance software, and the control is looking at the path and determining its motion to get inside. So I've heard people tell me that they can load a part, bring it out, they can index a turret and have a long boring bar or something sitting there, and then have it go in, and it will reprogram its own path to find another way to pick up that part out of the machine. So I think the most interesting part of it is it takes it to a level where literally anybody can run it. You don't need somebody that knows how to program a robot or integrate a robot to get automation up and going on your shop floor.
All right, and question for Rocky here. What is your current favorite Okuma machine tool in your shop?
It would have to either be the Multis U4000 or the Armroid. The Armroid, because of the robotic side, and I've been fascinated with that for several years of wanting to get some automation and robotics in there, but at the same time a little scared of, oh my gosh, want to spend days or weeks getting this set up, and we only have to make 100 parts. When this technology came along, it was like a perfect fit. So that was probably the one that has me the most excited at the moment. Prior to that, it was definitely the Multis U4000 that we're getting familiar with. And it's like I told somebody, really the only limitation on that machine is your mind. It's, you think of different things and different ways to do stuff with the main and the sub spindle and the lower turret. And that was one of the things I liked about the U series line over, different than the B, is having the lower turret to still work on main spindle and sub spindle at the same time. And our eventual goal long term with that is we have a couple of Cosmo PM600s, which are the only ones, as far as I know, in North America. We have two of them, and anybody that's in the audience that's been to our shop has seen them, and they're definitely different. So right now we do cylinder head manufacturing on that. And with the Multis U4000, we opted for that over the 3000, was the extra Y travel. And long term is we have the five axis simultaneous option there, is to do cylinder head manufacturing on the mill turn machine. And our intake manifolds currently are on a 5-axis machine, but we have to flip them from one side to the other on a pad. We have a fixture designed in house that we can straddle the manifold over, spin it 360 degrees, and get to all areas of it. So that'll be one of our upcoming projects here within the next 6 months or so, is to get manifold manufacturing also switched over to the Multis.
Nice.
All right, so we're going to close out our Q&A session here with a pretty fun question. So this is for both of you. What is your favorite NASCAR racetrack? Wade, would you like to start?
So I was always a Bristol fan. So I grew up watching the race at Bristol. Always enjoyed it. I used to watch Bristol back when the mountain was still there, before they mowed the mountain down. My wife's family is from Gray, Tennessee, so that's always been our kind of family track to go to and spend time at. So
mine is probably, I have to say two here for two different reasons. From the race team side, and when I was on the road and I was in the pits and stuff, those are the worst places to actually watch a race, is from the pit, standing on pit road or whatever. So Atlanta was always my favorite there. It was the only track that you could stand on top of pit wall, because you were down lower, you could see the entire racetrack. So it was a 1.5 mile track, but you could always see the cars. That one was my favorite from the race team side and being involved and standing on pit road. From a fan standpoint in the stands, it would be Richmond. The excitement at Richmond, Bristol's a big one. I always like Bristol. Richmond usually ends up having some pretty good racing and bumping and banging. Speeds are good enough for that. And then you can also see the whole track there really well.
Nice. All right. Well, thank you for joining us today. Make sure you follow us on all of our social media channels. You can find okuma.com. We're on LinkedIn, YouTube, Instagram, all the typical social media channels. Rocky, how's the best way to find more about Richard Childress Racing?
Yeah, so I want to thank everybody. First of all, thank you, Wade and Okuma, for hosting this event and letting me be a part of it. And also for all the fans that's listened in. And like Wade said in the beginning, if you're ever in the area of Welcome, we'd like for you to stop by. And if you're in the machining side of things, get in touch with Okuma and we can give you a behind the scenes tour of the facility, the shop, and the manufacturing side. Aside from that, you can follow us also on Twitter and Facebook and Instagram and all that. And if you go to rcrracing.com website, you can also see links to not only our primary sponsors and Dow and Caterpillar and stuff, but also our technical partners, Okuma and some of the other ones that we have.
Excellent. Thank you for joining us. We'll see you next time.